Okay, here we will explore the four main conic sections briefly so we can understand where they come from and how they kind of sort of look in general. In quadrant 1 of this grid, I'll do the circle because the circle is the one we probably all know and love. And the equation for a circle, the algebra of the conic, is x minus h squared plus y minus k squared equals to r squared. And of course, this is coming from the fact that it's a distance formula being applied to a center and a radius. So you can notice that your center is h comma k and your radius is r. Okay, the circle is the one that everybody knows because we need this one for all of trigonometry, and it's sort of one of the more basic shapes that we have. Okay, moving into quadrant 2, I'm going to now take that circle and I'm going to, instead of having it as an x minus h squared plus a y minus k squared, I'm going to do a stretch factor horizontally here and a stretch factor vertically. And when I do so, what I'm doing here, I put the 1 just because then we don't have to worry about getting these to be common or anything like that. So if we do it like this, then we're looking at 1, the unit circle with a shift, but then because of the stretch in the x and the stretch in the y, what we're doing there is we're elongating or shrinking the circle more in one direction than in another direction. And so what we're getting here is a kind of hot dog shape or a squished circle, and that's what we call the ellipse. Okay, in quadrant 3, we're going to change this now. We're going to go into the hyperbola. Okay, the hyperbola shape takes what we just did, the x minus h squared and the y minus k squared, does some stretching, a squared, b squared. But what we do this time is we subtract, and so one of the dimensions gets flipped over. And the shape that results here is called a hyperbola. And what's happening is that essentially you have a box that you're creating, whereas with the ellipse, there's a box that kind of surrounds this. In the hyperbola, there's a box, but that box allows you to be able to have these kind of shapes that come off the edge. So let me go highlight this in green. The actual shape of the hyperbola is this and this, but they get motivated by the same box that you can kind of see with the ellipse, but here they're going in an opposite direction. That's what creates the hyperbola. Okay, and then finally, the last major conic is a shape that you actually do know and love. It's called a parabola. But in conic forms, when we're dealing with conics, we usually think of this more as a y minus k times a 1 over 4p times an x minus h squared, because this allows us to be able to view the parabola in terms of its the geometry of where it's happening, essentially. So we all know a parabola shape generally looks like a y equals x squared, like this. But what the p allows us to be able to know is the distance from the vertex to what's called a focus, and then a directrix. And these pieces are important if you ever want to use these in acoustics. Okay, a couple notes about hyperbola and parabola in particular that's unlike circle and ellipse. The x's and the y's can be switched up. So if you switch the y and the x order and you subtract the x squared, your hyperbola can open up in a different direction. And similarly with the parabola, if you switch the roles of the x and the y, you can end up getting sideways opening parabolas. Okay, but these are the main four conics. The circle is the one we're hopefully already familiar with. An ellipse still keeps that plus sign, but has different numbers associated with the stretches of the horizontal and vertical components. The hyperbola takes that plus and turns it into a minus, which flips over one of the dimensions. And then the parabola, you're only squaring one of the variables, just like we have been doing with polynomials in Algebra 2. Hope this helps.